Hello everyone, welcome back to my YouTube channel. My name is Ved Prakash. In this video, we will talk about activation functions in deep learning. If you are watching this video, please do not forget to subscribe my channel and like the video. It will give some confidence to me to create more videos. Before starting, if you are looking for more in-depth explanations and resources, make sure to check out the link to my blog geekycodes.in the description below. In the process of building a neural network, one of the choices you get to make is what activation function to use in the hidden layer as well as at the output layer of the network. Elements of a neural network. There is input layer. This layer accepts input features. It provides information from outside world to the network. No computation is performed at this layer. Nodes here just pass on the information, that means features, to the hidden layers. Then comes hidden layer. Nodes of this layer are not exposed to the outer world. They are part of the abstraction provided by any neural network. The hidden layer performs all sorts of computation on the features entered through the input layer and transfers the results to the output layer. Then comes the output layer. This layer brings up the information learned by the network to the outer world. So what is activation function? Activation function decides whether a neuron should be activated or not by calculating the weighted sum and further adding bias to it. The purpose of the activation function is to introduce non-linearity into the output of a neuron. This is sigmoid function. At z is equal to 0, a is equal to 0.5, and when z is very large positive number, a is very close to 1, as you can see here. And when z is very large negative number, a is very close to 0. Sigmoid function used to be widely used as activation function in the hidden layers of a neural network. However, as you can see, the function is pretty flat beyond +3 and -3 region. This means that once the function falls in that region, the gradients become very small. This results in vanishing gradient problem that we will discuss later. And as the gradients approach to 0, network does not really learn. Another problem with the sigmoid function is that the values only range from 0 to 1. This means that the sigmoid function is not symmetric around the origin. The values received are all positive. Well, not all the times we would be desire that values going to next neurons should be of the same sign. This can be addressed by scaling the sigmoid function, and this brings us to the next activation function, that is hyperbolic tangent. This is hyperbolic tangent function or tanh function. It is very similar to the sigmoid function, and it is actually just a scaled version of sigmoid function, but unlike sigmoid function, it is symmetric over the origin. It ranges from -1 to +1. However, although it overcomes the lack of symmetry of the sigmoid function, it also leads to the vanishing gradient problem in very deep learning neural network. The rectified linear unit or ReLU function is the most widely used activation function when designing neural networks today. In addition to it being non-linear, the main advantage of using ReLU function over the other activation function is that it does not activate all the neurons at the same time. According to plot here, if the input is negative, it will be converted to 0 and neuron does not get activated. This means at a time only a few neurons are activated, making the network sparse and very efficient. Also, the ReLU function was one of the main advancements in the field of deep learning that led to overcoming the vanishing gradient problem. Then comes Softmax function. One last activation function that we will discuss here is the Softmax function. The Softmax function is also a type of sigmoid function, but it is handy when we are trying to handle classification problems. The Softmax function is ideally used in the output layer of the classifier, where we are actually trying to get probabilities to define the class of each input. So if a network with 3 neurons in the output layer outputs 1.6, 0.55, 0.98, then with a softmax activation function, the outputs get converted to 0.51, 0.18, and 0.31. This way, it is easier for us to classify a given data point and determine to which category it belongs. In conclusion, the sigmoid and tanh functions are avoided in many applications nowadays, since they can lead to vanishing gradient problem. The ReLU function is the function that is widely used nowadays, and it is important to know that it is only used in hidden layers. Finally, when building a model, you can begin with using ReLU function, and then you can switch to other activation function if the ReLU function does not yield a good performance. Now that is all about activation functions. If you have liked the video, then please do not forget to subscribe, and see you next time. Thank you.